Hello, and welcome to Summarize Science, where we break down complex research into simple concepts. Today, we're looking at a huge problem for our growing smart cities: traffic. We have cameras everywhere, but sending all that video data for smart AI analysis is slow and clogs up our networks, making real-time responses impossible. But what if we could send only the important information? This paper proposes a clever solution using what's called semantic communication, which is like sending a detailed summary instead of the whole book. Here is the overall workflow. First, at the edge, meaning on the traffic camera itself, an AI model called YOLO V11 spots the vehicles in the frame. It intelligently crops out just these cars and their immediate surroundings, ignoring the sky, buildings, and empty road. This already saves a lot of data, but the next step is the real game changer. A second AI, a vision transformer, looks at each of these small cropped images. It then converts the image into a tiny, compact piece of data called an embedding vector. Think of it as a digital fingerprint that captures the essential meaning of the image: the car, its direction, and its context. This tiny fingerprint is what gets sent over the network to the cloud, not the image itself. This process results in a staggering 99.9% reduction in the amount of data that needs to be transmitted. Once the tiny data fingerprint arrives in the cloud, a decoder uses it to reconstruct the original cropped image. A powerful AI, a large language model named LLVA, can then look at this reconstructed image and answer questions like, what are the cars doing, or is there a collision risk? But how good are these reconstructed images? This chart is incredibly revealing. On the left is the original image, and in the middle are images reconstructed using their method under different wireless signal qualities. Even with a poor signal, the image is still very clear. Compare that to the column on the right, which shows a standard transmission method that turns into a pixelated mess under the same poor signal conditions. So what's the trade-off for this massive data saving? The AI's accuracy in describing the traffic situation only drops from 93% to 89%. That's a tiny price to pay for such a monumental leap in efficiency. So, to recap the key points, this system uses AI on the camera to find what's important, compresses it into a meaningful fingerprint, and sends that instead of the raw image. This slashes data transmission by 99.9% while keeping the AI's understanding of the traffic scene almost perfect. What does this mean for the future? It paves the way for truly intelligent transportation systems. Imagine traffic lights that adapt instantly to prevent accidents, or emergency services being dispatched automatically before a crash is even reported. This research is a huge step towards making that a reality. Thanks for watching Summarize Science.